All right, I didn't write. I erased the section. Sorry, but that's okay. This is section 3.4. I'll write that at the top if I could get my writing utensil here. There it is.
The thing looks so cool.
What does?
The
pad thing. Yeah, just writing on nothing.
When you're moving the mouse, you don't touch it.
Right. Yeah, I don't even have to touch it. Yep. See, it's moving around like that. You just get kind of close. Now, if you get far away, it won't. Okay, but if you get pretty close, it moves without touching the pad. Because if I touch the pad, then it writes.
Right.
Unless I'm on this, the arrow tool, but it does that if you touch the pad.
And all it is like a click of a button.
Yeah, I hit N to hit the pencil, and then if I want it like a thicker, like a brush, hit B. That's the N, and that's the B. That kind of stuff. And if I hit V, then it turns to that pointer tool, and I can select it and erase it. That kind of thing. Isn't that cool? Isn't that exciting? Yes. Now, yeah, it's my little demonstration for
YouTube. Now, when you title that
YouTube.
video, you can call it Section 3.4 and Sidetrack.
Yeah. Well, I could call almost every lesson I do sidetrack because I tend to do that once in a while. All right. I don't know who the Eagles are.
Andy Reid.
All right, here we go. Good try, but it's not going to work this time. All right, let's do a little X and Y axis deal here. Oh, that first one's a little squiggly. I don't like it like that. All right, let's do an X and Y axis. What did we talk about yesterday? What was the main focus of yesterday's lesson? The slope. Okay, we're going to talk about it again, but what do you think comes next after the slope?
Slope-intercept.
Yeah, slope-intercept form, which is basically just what?
Isn't it Y?
It's just
Y equals X.
Yeah, but let's write it like this. What do we call that? We call it an equation, what?
Line?
Of a line.
Oh, really?
Yes. You sound surprised. All right, it's called an equation of a line. That's what we're going to do right now. Now there's several different, I don't know if there's more than this or not, but I think I've studied at least 4 or 5 probably different equations of a line. Right today we're just going to learn 2 of them, okay? The first one is the one you're probably most familiar with, and somebody said it already. They call it the slope-intercept form, and that is y equals mx plus b. Okay. They call this the slope-intercept form. We'll talk about why they call it that in a second. Let's just write it down. Intercept, C-E-P-T. All right, that's the slope-intercept form. Basically, because of this reason right here, let me show you. See this point right here? It crosses the y-axis. There's a lot of times, especially in the sciences and things like that, where the point that crosses the y-axis is a very important point. And I taught physics for a lot of years, and we talked about that particular thing. We call this, it's where it crosses the y-axis, we call it the y-intercept. And I just put INT for short, okay? But intercept, it's where it crosses, where it intersects the y-axis, we call it the y-intercept. Now, there's also an x-intercept as well. But in this formula, we don't use the x-intercept, okay? We just use the y-intercept. Everybody okay with that? Now, what letter do we use to represent the y-intercept?
Y.
You'd think we would, but it's B. Right, it's B. Do you guys in Korea use that same y equals mx plus b? Yeah. You don't use like Korean letters, and you just use regular English letters like that? Okay. Yeah, because I had a Korean friend. I told you this before. In college, I had a Korean friend. He was really good at math, and I was looking at his math, and all the stuff he was writing was like all in English, and it surprised me. I don't know. I thought you guys, like if you did Y or X, I don't know. I just thought you had your own words. I guess that's kind of a universal thing. So no matter what country, you kind of do the same letters. Okay. All right. So that's the y-intercept. We use B. Any idea why we use B? I looked it up one time, and if I remember right, I think they use A for the x-intercept, and they use B for the y-intercept. Make sense? All right, so that's why we use the B. But we hardly ever talk about the x-intercept. There are times when we'll talk about it, but in this example, or this form, we don't talk about the x-intercept. All right? So we talk about the y-intercept. What's the other thing? We talked about it yesterday. We talk about the what?
Slope.
The slope. All right? And we talked about this yesterday. What is the letter for slope?
M.
It's M. Okay? EM. EM? Okay. So that's the slope. So there we go. Watch. There's the slope right there, and there's the B. That's supposed to be a B. It's kind of weird. But that's the y-intercept. The x and the y, they just stay x and y. So for instance, if I told you the slope was, we'll make it real easy, like 2/3, and I said the y-intercept was -5, and I asked you to take that information and put it into the slope-intercept form, it doesn't get any easier than this. Okay, if they straight up tell you what the slope is and what the y-intercept is, it's just plugging and chugging, right? You don't have to do any math, you don't have to figure it out, just put it in there. So what would it look like? It would be y equals what? M, which is what? 2/3 x, right, it would be -5. Okay, plus -5, same thing as -5. But look at the x and the y. It just stays x and y, doesn't it? It doesn't turn into another number or anything like that. It just stays the letter x and the letter y. Well, listen to this. This x and y actually represent any point on this line right here. So whatever point that was, okay, the x part of that point would go here, and the y part of the point would go right here. Does that make sense? Now obviously this is not the equation to this line because the y-intercept's -5, so it would cross down in here, wouldn't it? Alright, but I'm just doing this for an example. So this x and y would be a point on that line. Or I could pick another point on the line, and I could put an x here and the y here from that particular point. I'm not just picking any random point in the world, am I? I'm picking a point where? On this particular line. You with me on that?
Middle school cross country and middle school volleyball are now dismissed.
Okay. Alright, so watch the rest of this on YouTube and do last night's homework tonight. Okay. Alright, so are we okay with that? That's the slope-intercept form. We're going to do an example where they don't just give you the slope and the y-intercept. We're going to have to figure it out. Okay, we're going to have to figure out what the slope is, and we're going to have to figure out what the y-intercept is. Good luck, ladies. Alright, so we'll get to that a little bit later. Alright, let's talk about another form. This is the slope-intercept form. And notice, it's not like it was a stretch to call it the slope-intercept form, right? Because what do you have? You got a slope and you have an intercept, okay? Now it happens to be the y-intercept, but it's a slope and it's the intercept, all right? Not brain surgery to come up with that name for it, is it? You don't have to be that creative. Here's another one that you don't have to be all that creative for. It's called the point-slope form. Point-slope form. Now, on this form, now these are all equations of a line. On this form right here, what do you think they're going to give you? A point and a slope. Now, this point isn't necessarily going to be the y-intercept, is it? All right, it'll just be some point on the line. Again, I'm just going to make one up. Let's say -3, 2. All right, and let's say the slope is, I don't know, let's make it negative this time, 1/4. Is that all right? So what if the slope is -1/4 and this is one point on the line? You with me? So I got a point on the line and I got a slope. That's going to represent one particular line. And so if I want to write it in the point-slope form, here it is. You might have seen this before. Do you remember this? Y minus y1 equals m times x minus x1. Does that look familiar at all?
Yeah.
Yeah? You hated this one?
I couldn't memorize
Okay.
it.
Alright, it's not so bad. Right? This is kind of like the change in y. This is kind of the change in x times the slope. Alright, it's the point-slope form. Now watch. Just like over here, remember I said this x and y just represents any point on the line, and it just stays x and y, right? When we write the final answer out, we don't make that into a number, we don't make that into a number. It just stays the letter x and it stays the letter y. Down here, this just stays the letter y, and this one just stays the letter x. Now the x1 and the y1, where do you think you get those from? From this point right here. Okay, so if they give you a point, this would be the x1, that's supposed to be a 1, and this would be what? The y1. Does that make sense? So the x and the y's with the 1 down next to it, that's the actual point that we're using. Okay, so if I wanted to, here we go. Again, they're not going to make it this easy, but let's say they give you a point, they give you a slope, and we want to write it in the point-slope form. This is what we would do. We go y, what? Minus y1. So it would be what? Minus 2 equals m. What's our m? It's -1/4. It's supposed to be negative right there. Parentheses. Okay, x, we just keep that the letter x, minus what? -3. What's minus and negative? Say it. Plus, right. So it's going to be plus 3. Everybody see that? And that right there is the point-slope form. And you just leave it like that. If they tell you to write it in point-slope form, you would leave it like that. But there are some times they're going to say, write the answer in slope-intercept form. So we have to take this and we got to transfer it and make it into slope-intercept form. So let's do that just for fun, all right? So let's rewrite it again, okay? Just so that I'm working right below it. Everybody good with this? So if we want to change it to slope-intercept form, if you look at slope-intercept form, basically all you got to do is just get y by itself, right? And then get just one x and then a number on the outside. It's actually pretty easy. So first thing I'm going to do, a lot of people say, oh, take that 2 and move it over here. Don't do that yet. We will in a second, but not right now. What do you think we'll do first? Yeah, distribute this. So that's going to give us what? Negative 1 fourth x minus 3. 3/4. That's right. It's going to be 3/4, isn't it? Because it's 3 times a fourth. All right. Now I distributed. Now I can add the 2. So if I add a 2 here, I got to add a 2 over here. Now watch. Let's think a little bit. Instead of putting a 2 over 1, I'm adding it to this. All right. So I need a common denominator. What am I going to put here?
4.
I'm going to put a 4. What's this going to be? It's going to be 8. Right. You follow me? That's a 2, isn't it? Isn't 8 over 4 the same thing as 2?
Yeah.
You can do that in your head, can't you? All right, just do it like that. So instead of putting a plus 2 and then trying to find a common denominator, just think about it first, okay? I got to add it to something with a 4 denominator, so I make it 8 over 4. That makes things a little bit easier. Had a couple people in the last class really confused on that. But if you're okay with your fractions, then that shouldn't be that big of a deal. All right, so here we go. What is it? Negative 1/4 x. What's this going to be now? Plus what? 5/4. Okay? And that, this and this are the same exact line, except this is written in point-slope form, and this is written in slope-intercept form. All right, this tells you exactly where it's going to hit the y-axis. It's going to hit the y-axis at 1 1/4. You see it? Still got the same slope, right? There you go. If you were to graph it, if I gave you something, let's just make one up. I'll put it in different colors since I got red all over the place here. Green. What if I gave you this, like y plus 3 equals 2/5 x minus 1? What if I gave you this and I asked you to graph it?
You distribute it.
Well, you wouldn't even have to do that. You could look at it and realize, okay, there's a point. What is the point?
3, negative 1, or negative 1, 3.
Let's think. Remember,
Oh,
remember, it's, where is my equation? There it is. It's x minus x1, right? So what's my x1 going to be? Just a 1, not a negative 1, just a 1, because my equation says x minus whatever the 1 is. What's my y going to be? It's going to be negative 3. You see that? Because it's y minus a negative 3. You see that?
Yeah.
So my point is going to be 1, negative 3. So if I was to graph this, so that's my point, and what's my slope? It's just 2/5. So it's really easy to graph it. I don't have to change this to slope-intercept form. If all I had to do was graph this thing, I just find my point, 1, negative 3, plot it, right? 1, negative 3, plot it, and 2/5 is my slope. 1, 2, 1, 2, 3, 4, 5, plot it, boom, there's my line. Make sense? All right, so you could very easily do that if it was in point-slope form. To tell you the truth, this is most people's favorite. And this is the one that they probably use more than anything in the book, is the slope-intercept form. So this is the main one that we'll use, even though you could use this as well. All right, and we're going to talk about both of them, but this really is the predominant form that we're going to use. We good?
Got it.
All right, let's do an example or two, and then we should be done.